Here we are. We're doing Chapter 3, Section 4, Product and Quotient Rule. As I mentioned before, you do not have a rule up to this point for how to take the derivative of two things being multiplied. You do for two things being added or subtracted. But here's what we're going to see. I am multiplying two functions, and I want the derivative of that. Well, here's your rule. You take the derivative of the first one and leave the other one alone. And then you add to that, you leave the first one alone and take the derivative of the other. Now, these could be in any order. So you could do this, f of x g prime of x plus f prime of x g of x. It doesn't matter, they're both the same thing, because addition is commutative. You can flip those around. So in essence, what's going on here? This is really easy to remember. You leave one alone, take the derivative of the other. You leave the other one alone and take the derivative of the other one, and you add them. So that's an easy rule to remember. This is the product rule. You will use this all the time. You've got to get this. You cannot just take the derivative of one, take the derivative of the other, and combine them. It doesn't work. You have to use this rule. So here are some examples that we need to try, and you can pause and try it on your own, and I will work this out. So here's how we're going to do it. We'll consider this function f. I'll underline it in yellow, gold, and we'll consider this function g, and I will highlight that or underline it with the fuchsia. And I am going to write it this way. Yeah, I don't like the way it's written, but I'll say the derivative equals. Yeah, this equals. So you leave the first one alone. Don't do anything to it. Then you take the derivative of the second one. Well, 2 is a constant, I leave that. The derivative of square root of v, hopefully you are at the point where you know it's 1 over 2 radical v. And the derivative of a constant is 0. And then you go the opposite. Now you take the derivative of the first one. Using the power rule, the 2 comes in front, so it becomes 2, and you subtract 1 from the power, it becomes to the first. So you take that and minus 1, you get a first power. Then you leave the second one alone. So I'm going to leave that as it is. And that would be the derivative of a. Now, simplifying this gets kind of crazy. I'm seeing if we can, let me rewrite this. Those 2's cancel, so that's going to be over v. And then I'm going to get, oopsies, I'm going to distribute that. It's going to be a 4. V times radical v plus 1. A little bit more. This is v to the 1/2 power. This is v to the 1/2 power. And you need to know this. Exponents with the same base, you subtract that. That's going to be v squared minus 1/2. There's a 1 there that you don't see. So the rule, you add the exponents. And a final answer is v to the 3/2 plus 4v. Whoa. Is this really happening? That is so cool. We have the same thing. So we have 1 here and 4 there, so that gives us 5 of them. Now, how do we get 5? I'm just going to throw out some algebra here. What really happened? Why did we get 5? So let me erase this and show you why we get 5. We really factored. You noticed we had a common factor. If we take v to the 3/2 out, I'm left with 1 plus 4 plus 1. Because if I take this out, I'm left with 1. If I take that out, I'm left with 4. If you add those up, 4 plus 1 is 5. So that's really why it's 5. But I think of it as I have 4 here, I have 1 here, I add them up, I have 5. So that's the answer to part A. Now we're going to do part B, and we have product rule again. And I think I'm going to erase this stuff because I'm running out of room. So you can pause and copy this if you need to. I'm going to erase all of this down below and start all over. So let me delete that. So now I'm in part B, and the derivative will equal. And you see that there's two things being multiplied. X squared and the second, e to the x. So I need to multiply those two together. So how do we do that? Excuse me. On that last problem, I actually think I made a mistake. Let me go back and look at something. See if I can go back enough. Yeah, some of you may have caught that. That's so bad. If I distribute that, I get 2v there. So this is actually 2v. Yoshida, what are you doing? 2v, 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 2v. I think 2v is actually someone's name. All right, sorry about that, folks. Now let's go back, and I'm going to erase all this, and we're going to do the second one. And like I said, we're multiplying two things, x squared and e to the x. So my product rule, what does it say? Well, I leave the first one alone, and I take the derivative of e to the x. But you should know the derivative of e to the x is e to the x. And then I take the derivative of the first one, which will be 2x, and then I leave the second alone, it's e to the x. This one's easy. Do I have a common factor? They both have an x, they both have an e to the x, so I'm going to take that out. And what will be left? Well, if I take out an x and e to the x, since there's two of them there, I'm left with an x. And if I take out an x and an e to the x, I'm going to be left with a 2. Bam! There is my answer in factored form. All right, that is called the product rule. The next one we're going to cover is the quotient rule. Okay, this one's a little trickier. So let's read this. F and g are differentiable, and the denominator is not 0. Or else we'd have a discontinuity, and the derivative will not exist. Okay? So what's the derivative of one function divided by another? And here's how I remember. I call the bottom one the low function, and the top one the high function. So this is the low, derivative of the high, so I say low d high, minus, this is the high function, this is the low function, but it's the derivative, so this is going to be high d low. So I have low d high minus high d low, and the bottom one is low squared. So that's my method. Low d high minus high d low over low squared. Now you can come up with your own method to memorize that, but you just have to memorize that. That has to be known. I have students mess this up where they switch these two. That does not work. It'll be wrong. You have to memorize this, and the more you practice, eventually it will just be in your brain. It will be in your brain. So this first one, I need low. Low is x squared plus 1. So I do x squared plus 1. Then I need d high. What's the derivative of that? It's going to be 2x plus 3. 2x plus 3. Minus high. The high one is this one, so I copy that down. Times the derivative of the low one. I need the derivative of that. I bring the 2 in front, becomes 2x. That's going to be 0. All over low squared. Okay, the bottom, you don't want to square that. You want to factor and cancel. You want to simplify things. That is your goal. So what can we do at this point? I'm going to see if there's simplification we can do. I don't see any common factors on top. This one and this one, I don't see anything in common. This has an x, no, I see nothing. So when I see nothing in common, I want to just multiply that out. I just want to multiply it and see what happens, and hopefully nice things happen. So here, I need to distribute the x squared, and I need to distribute the 1. And same thing on this one. I need to distribute the 2x and the negative. So let me get all that on top here. So we will get the purple 2x cubed plus 3x squared. And then I'm going to have the gold, these golds. So that's going to get me plus 2x plus 3 minus, and be careful, you're subtracting everything that comes after this. I won't distribute that minus. I'll just leave it right there. But I need to distribute the 2x to all 3 of these. So that's going to get me 2x cubed plus 6x squared plus 8x. Now I distribute the negative, so I will do that. But the bottom is still x squared minus 1 squared. And then I'm going to combine like terms on top. But let me first do this. I'm going to distribute this minus sign. So that will give me a minus on all of those. So minus 2x cubed minus 6x squared minus 8x all over x squared minus 1 squared. Now I combine like terms. 2x. Oh, how cool. Those are going to disappear. I'm so happy. Gone. Gone. Now I combine my x squareds. 3x squared minus 6. That's going to give me minus 3x squared. I can handle that. And then my x's, I have 2x minus 8x. That's going to be minus 6x. And then my last one that I have left is constants. I have a plus 3. So I'm going to have a plus 3 left all over x squared minus 1 squared. On top, I want to factor out the negative 3. That leaves me with the x squared plus 2x minus 1 over x squared minus 1 squared. Is that right? Let me see what's going on. I'm having so much algebra going on. Hopefully we're good. I think we're done. I think. I actually think I made a little algebra error somewhere. Let me double check. Because I'm peeking at the book answer and they are getting a 10 instead of a 6 here. So let me double check. This 2, let me see what's going on. I'm going to go through this whole thing. Sorry, guys. So, low. Oh, there's a minus there. I am so sad. Okay, that's going to change a few things. So, that's still the same. And then that's the same. This is going to be minus 2x and minus 3. So that's going to change things. I am sad. I'm sorry. Minus 2x minus 3. And then I get high d low. I'm subtracting that. So I get 2x cubed, 6x, 8x. And then let me fix this next line. That's going to be minus 2x minus 3. And then we're looking good on the rest. Now we combine like terms. Those still cancel. And then 3x squared minus 6x squared. That's going to get us minus 3x squared. We're still good. Minus 2 and minus 8 is minus 10. Yoshida, why are you wasting time? And then, and I'm too lazy to remake this video for you guys, sorry. We're going to be left with a minus 3. So let's make that a minus. And that changes a few things. Oh, yeah, that changes a lot of things. That gives me my answer. That is the answer. I am done-o. Let's do example B because I like example B better. You can pause this and you can erase things as needed, but I am going to clear this out and start with B. And you might look at B and say, that's not a quotient. How do I use the quotient rule? Remember, this can be rewritten because of the negative exponent. You move it to the bottom. It becomes 1 over e to the x. Now you have a high and a low. This is the high, this is the low. So the derivative for B will be low, so I copy e to the x. There's my low. And then d high, well, what's the derivative of 1? That's a constant, so that derivative is 0. Minus low, this is the low, so I copy e to the x. Wait, low d high, sorry, I am a liar. I already did that. Low d high, now I'm going to do minus high d low. So high is just 1, so I copy 1. The derivative of the low is just e to the x, all over low squared. Wow, this one really easy. Do I have e to the x minus e to the x? Is that possible? Oh no, I am so bad right now, making too many videos. This times 0 is 0. Anything times 0 is 0. So I have negative e to the x over e to the x squared. So one of the e to the x on top is going to cancel with one of the e to the x's on the bottom. That's going to cancel with one of those. And I will be left with negative 1 over e to the x or negative e to the minus x. Either one is fine. You have to understand both are the same. That is quotient rule. So be careful when you have negative exponents. Okay? Now, I will quickly do this extended power rule. Before, when we had the power rule, your n had to be a positive integer. Now they're extending it and says it works with any integer. I've already told you it works with any rational number. We're going to get to that. So we're just going to use the power rule here, and we have a couple of examples, and then we have the crazy one at the end. So here we go. We want the derivative of this. That is a quotient. This is a high, and that's a low. So when we take the derivative for a, it's going to be low, which is x to the fifth. D high, the derivative of 9 is 0, minus the high, which is 9, and the derivative of the low is 5x to the fourth, all over low squared. Well, this one's pretty easy. That's 0, and we are left with negative 45x to the fourth. And when you raise an exponent to a power, you end up multiplying those. You need to be comfortable with that. That needs to be easy for you. And then 4 of these will cancel 4 of those, leaving 6 on the bottom. So it's negative 45x to the sixth. Or if you prefer, you can move it to the top and get that. Either one's fine. But you need to be able to jump back and forth between those two. All right. Uno más. I will do B. We're getting crazy stuff here. It's going to get more complicated, so please keep up with us. We have a quotient rule. We have a high function and a low function, so we're going to do the same low d high. So low is t to the sixth. The d high, we move the 16 out in front and decrease the power by 1. So low d high, Sorry, that's, whoa, that low d high, yeah, I'm good, sorry. The derivative of 4 is 0, that's why there's nothing there. Minus high d low. High is 3t to the 16th minus 4. D low, power rule makes it 6t to the 5th. All over low squared, t to the 6th squared. We have a lot of algebra going on here, folks. A lot of algebra. So, I could factor it before I do this, but yeah, maybe I will do that to make life easier. Do you see we have a t there and a t there? No, I'm going to multiply it out first. I'm going to simplify. I think it'll make life easier. So on this side here, that's going to give me what, 48? And then t to the 21. 48 t to the 21 minus, and then I need to distribute here and here, here and here. So minus 18 t to the 21 and minus 24 t to the 5th all over t to the 12th. I distribute the minus to both of those, and I will get 48 t to the 21 minus 18 t to the 21. Hey, I like that. Plus 24 t to the 5th. Remember, the minus becomes plus. All over t to the 12th. I'm seeing things I like. I have a common factor of 21. If I take that out, 48 minus 18 is 30. Or I have 48 of them minus 18 of them. I have 30 of them. I have 30 t to the 21s. And then we have this all over t to the 12th. But you will see they both have a 3 in them. And they both have a t to the 4th in them. So I will take out 3 t to the 4th. And that will leave me 10 t to the 17th minus 8 all over t to the 12th. And 4 of these will cancel out 4 of these, leaving 8 on the bottom. So my final answer is 3, 10t to the 17th minus 8 all over t to the 7th. Hopefully that matches what the book has. I will take a look-see. Oh, it's not the same as oh, you know what? The book did. Okay, I might have the same thing as the book. They actually simplified it and divided it out. I'll show you what they did. Let me make sure I got the same thing. 24t, yeah. They divided this into each of them, and they left the 3 in there. So, same answer. I'm just going to leave it like that. We'll stop there. Here is the crazy one. So, there are so many things going on, and you might be confused what to do. There's a 4x times e to the x. That's a product rule. Then, you also have a high function, and you have a low function. Do you do the product rule first, or do you do the quotient rule first? What do you do? Well, part of it is understanding rules of algebra. This fraction bar right here, that implies parentheses. What I mean by that, there is an implied parenthesis around the bottom and around the top. You don't see it, but it's implied by this fraction bar. So if you see that, you should see you have a quotient rule first. You have a low and a high. So this is understanding what symbols mean. And so we have the whole bottom dividing into the whole top. That is a quotient. And in the top, you have a product. So I'm going to do low d high. Low d high. I need the derivative of that. I'm going to do side work. This is side work. I'm going to say y is 4x e to the x. And I want y prime. This is side work. I recommend this. It's going to make your life easier. We have a product. So I leave the first alone and take the derivative of the second. And then I take the derivative of the first and leave the second alone. So that is the derivative of the top. That's d high. So d high is 4x e to the x plus 4 e to the x. That's low d high minus high. I just copy the top one. And d low, the derivative of the bottom is just 2x. All over low squared. That is ugly, but that is that. Low d high minus high d low. Okay, we did that. So all this equals, yeah, sorry guys. I'm going to do some ugly work here. So this is going to be a lot of stuff going on. Do I have anything in common on top that I can take out? I'm going to have to distribute. I'm hoping that I didn't make any ugly mistakes, but basically I have to do that, that. So that's what I'm going to do. So the first one I'm going to do is that, and that's going to get me 4x cubed e to the x. Then I'm going to do that. That's going to get me 4x squared e to the x. And then I'm going to do that. That's going to get me plus 4x e to the x. And then I'm going to do that. That's going to give me plus 4e to the x. And I need to clear this out of the way. It's in the way. This is my side work here. Then I'm going to do minus the rest here. That's going to be 8 x squared e to the x. And that's going to be all over. And I don't want to multiply this out. It's already factored. I don't want to defactor that. Now, on top, are there anything the same? X cubed e to the x. Are there any more x cubed? Nope. X squared. Ooh, look at that. X squared e to the x. X squared e to the x. 4 minus 8 of them. That's going to give me negative 4 of them. Whew. This is a lot of things going on. Negative 4 x squared e to the x plus 4x e to the x minus 4 e to the x all over this. And let me show you what happened. I combined that and that to get negative 4. Everything else copied down. Oh, that's a plus there, huh? Good thing I double checked. Almost done. Is there anything all of these share in common? Yes. They all have a 4. I'm going to take that out. They all have an e to the x. I'm going to take that out. Whoa, what happened to my e to the x's? I'm going to take those out. So I'm going to take 4 e to the x out. Here, I'm left with x cubed. Here, I'm left with x squared. Here, I'm left with x. And here, everything's gone, so I need to put a 1 there. Now, this might be factorable. Nah, I don't think it is, actually. I think that's my answer. Hopefully it matches the books. It looks like it does. That was ugly, I confess. But that's the end of the lesson. Bye.